Hello dear friends, welcome my channels. Today's discussions is multiple integrations. So friends, I want to discuss the list of formula. These formula are very important. What is the formula? The formula is 0 to infinity e to the power minus at t to the power x minus 1 dx gamma x divided by e to the power x. So friends, at first we need to know what is gamma. Gamma is 0 to infinity e to the power minus t to the power x minus 1 dx is equal to gamma x. So friends, e to the power at t to the power x minus 1 dx gamma x divided by e to the power x. So it can be proved easily when we take at is equal to z, then t is equal to z by e, and gamma x plus 1 is equal to gamma x plus 1 is equal to x into gamma x. Beta x plus 1 is equal to x comma y is equal to beta yx is equal to 0 to infinity t to the power x minus 1 plus t to the power x plus y into dt, and 0 to infinity t to the power y minus 1 plus t whole to the power x plus y into dt, and beta xy is equal to 0 to 1 t to the power x minus 1 and 1 minus t whole to the power 1 y minus 1, and if t is equal to 1 plus u, then we can get these equations easily, and beta xy equal to gamma x into gamma xy gamma y to gamma x plus y, and number 6 is 0 to pi by 2 sine to the power 2n minus 1 cos to the power 2n minus 1 theta is equal to half of beta into x comma y. Another formula is root over pi gamma 2x equal to the power 2x minus 1 gamma x into gamma x plus 1 x plus half. So friends, this formula is duplication formula, friends. This formula is duplications formula. So how to prove legendary duplications theory? This is very interesting problem. It is very interesting how it is proved. So friends, let's start to prove this duplications formula, because as so friends, beta xy, let's start, beta x comma y equals to gamma x into gamma y divided by gamma x plus y. So equals to, we can write 2 into 0 to pi by 2, we are discussing sine to the power 2m minus 1, so 2x minus 1 dx d theta, 2x minus 1 d theta into cos 2x minus 1, 2 into 0 to pi by 2 into sine theta cos theta to the power 2x minus 1 d theta. And now we multiply the 2 into 2 to the power 2x minus 1 into 0 to pi by 2 2 sine theta cos theta 2x minus 1 d theta equal to 2 divided by 2 to the power 2x minus 1 integration 0 to pi by 2 sine 2x minus 1 2 theta d theta. So friends, I hope I can clear this portion. And now because sine 2 theta means 2 sine theta into cos sine 2 theta, and now we will go to the another portion, that gamma. So friends, take y is equal to half. So it can be written 0 to pi by 2 sine 2x minus 1 into theta cos to the power 0 theta d theta, and 2 theta is equal to theta, I can say. So 1 by 2 to the power 2x minus 1 equals to gamma x into gamma x divided by gamma 2x. So friends, this is the main factor, that is gamma x into gamma x divided by gamma 2x, and this equation is considered 1 by 2 to the power 2x minus 1 divided by gamma x gamma half divided by gamma x plus half. So whatever I get gamma x into gamma x divided by gamma 2x is equal to gamma x gamma half divided by gamma x plus half. Now I can cut this portion, gamma is gamma x. So whatever I get gamma 2x and gamma half is equal to root over pi. So root pi into gamma 2x is equal to gamma x plus half. So friends, whatever you will see root over pi gamma 2x is equal to 2 to the power 2x minus 1 gamma x into gamma x plus half. So this formula is very, very important for solving a lot of gamma problem. And another is gamma m into gamma 1 minus m is equal to pi cosec m pi. So friends, I am discussing some formula. Now I will solve some problem. First problem is triple integrations x to the power alpha and y to the power beta and z to the power gamma is equal to 1 minus x minus z to the power lambda and dx into dy into dz. So friends, this is the must remember, that is the x and x plus y plus z equals to 1. This is the Dirichlet integral. This integral is called Dirichlet integral. So friends, x plus y plus z equals to u, let. So friends, that implies I take this, it is u. After that, x plus y equals to uv and x is equal to uv w. After that friends, we can write this way, u is equal to x plus y plus z. So v equals to x plus y divided by x plus y plus z. So friends, j equals to del x y z divided by del u comma v comma w. Equals to u square into v. U square into v. Now I equals to, so friends, what is the main problem? This is the Jacobian. Jacobian is transformation. Transformation is u squared by v, because Jacobian formula is determinant del x by del u and del x by del v plus del x by del w and del y by del u, del y by del v and del y del z by del w. So friends, I equals to 0 to 1 u to the power alpha plus beta plus gamma plus 2. How big? Because friends, you will see, because just putting the value of xyz. So friends, x is equal to uvw. I must write in here. So y equals to uv into 1 minus w and z equals to u into 1 minus v, and that's why just putting the value of x and y. So whatever I get u to 1 into e to the power lambda du into 0 to 1 v to the power alpha plus beta plus 2, 0 to 1 w to the power alpha into 1 minus w to the power beta. So friends, this is the formula of beta function. Friends, I have already told what is the beta functions. You will see that t to the power x minus 1, 1 minus t to the power t minus y, 1 into t to the power minus y minus 1 is equal to dt. So this is beta function. What is the beta function? Beta x comma y is equal to 0 to 1 t to the power x minus 1 into 1 minus t to the power y minus 1 into dt. So this is the beta xy. So I just putting the value of beta xy. So whatever I get beta alpha plus beta plus gamma plus 3 and lambda into 1 into beta alpha plus beta plus 3. Sorry, it is not 2, it is 1. So it is 2 comma gamma plus 1 into beta alpha plus 1 comma beta plus 1. So friends, I hope I can clear, because the formula is this, and alpha plus 1 and beta plus 1. Gamma alpha plus 1, gamma beta plus 1, gamma plus 1 and gamma lambda plus 1 divided by gamma alpha plus beta plus gamma plus 4. This is the answer, friends. Sorry, there is some mistake. That is plus lambda plus 4. How, friends? Now question is that how it is. So I just showing the calculations that beta alpha plus beta plus gamma plus 3 divided by lambda plus 1 equals to gamma alpha plus beta plus gamma plus 3 gamma lambda plus 1 and gamma alpha plus beta plus gamma plus 4. Another factor is, friend, alpha plus beta plus 2 into gamma plus 1 into beta alpha plus 1 beta plus 1 equal to gamma alpha plus beta plus 3 gamma plus 1 divided by gamma alpha plus beta plus gamma plus, this is 2, so this is 3. So this portion and this portion is cut. Into gamma alpha plus 1 gamma beta plus 1 divided by gamma alpha plus beta plus 2. So this portion and this portion is also cut. So friends, gamma lambda 1, gamma 1 and gamma alpha plus 1, this is the remaining portion. So I hope I can clear this concept. Now friends, we are going to solve another interesting problems. This problem is very interesting. Why? Because the problem is one technique. The technique I love this technique, because this technique help to solve a lot of problems. So let's start to solve this problem. At first, I can take this equation. This is take a IA I take it as a I0, okay, and I take it IA is equal to 0 to 1 and 0 to 1 and 0 to 1 and x y z whole to the power a divided by x y z whole square divided by log square x y z dx into dy into dz. And now I just derivative this portion, so whatever I get 0 to 1 and 0 to 1 and 0 to 1 and derivative of xyz to the power a with respect to a, so it is log xyz divided by 1 plus xyz whole square into log square xyz, and this portion cut, so it would be log xyz. So this equals to 0 to 1 and 0 to 1 and 0 to 1 xyz whole to the power a divided by 1 plus xyz whole square log xyz, and I will derivative another way, double derivative I double dash a into dx into dy into dz. So I get another way log xyz. So this portion and this portion is cut. So I double dash a equal to triple integration 0 to 1, 0 to 1 and 0 to 1 xyz whole to the power a and 1 plus x square y square z square dx dy into dz. Now there is the formula. Which formula? Formula is 1 by 1 plus x is equal to summation minus 1 to the power k. K is equal to 0 x to the power k. So I just apply this formula and write in here 0 to 1, 0 to 1 and 0 to 1 minus 1 to the power k divided by xy z whole to the power a summation k equals to 0 to infinity minus 1 to the power k xyz whole to the power 2k into dx into dy into dz. 0 to 1, 0 to 1 and 0 to 1, we get summation k equals 0 to infinity minus 1 to the power k x to the power 2k plus a y to the power 2k plus a and z to the power 2k plus a dx dy and dz equals to summation k equals to 0 to infinity minus 1 to the power k divided by 1 by 2k plus a plus 1 whole cube. And now I double dash a, this is I double dash a, I dash a is equal to summation k is equal to 0 to infinity minus 1 to the power k plus 1 a whole square. And similarly plus c and where a tends to minus infinity, c tends to c1 tends to 0 and I dash double dash a, sorry, I double dash, why I write IA equals to summation k equals to 0 to infinity minus 1 to the power k divided by 2 into 2k plus a plus 1. This is IA. Now a equals to 0, so I equals to 0. So whatever we get half into summation k equals to 0 to infinity minus 1 to the power k divided by 2k plus 1, and this value is arc tan theta, so half into arc tan 1, so arc tan 1 is equal to half into pi by 4 equals to pi by 8, and I hope that my answer is coming pi by 8, and now the answer is pi by 8. So friends, there is a lot of way, but this technique I like, that's why I solve this way. Again friends, we solve a complex analysis problem. This is, I can write this equals to I, and that implies I equals to 2 into 0 to infinity x plus 1 divided by x square plus 1 divided by d root over x, as d root over x is equal to 1 by root over x 2x dx. That's why I write this way, and after that I can write this I equals to I is equal to minus infinity to infinity t square plus 1 divided by t to the power 4 plus 1 into dt, where t equals to root over x and if t is equal to t square plus t to the power 4 plus 1. Using above contour, so friends, I draw a contour. Let's try to draw capital R, and this is C gamma, this point, and this is minus capital R, and this is the arrow is this way. This is the anti-clock, counterclockwise. This direction is counterclockwise. This direction is counterclockwise. Okay. So how can we write using the above contour C gamma versus CR, counterclockwise directions, and capital R greater than 1 tends to infinity. So friends, Z1 and Z2 are the two pole. So Z1 can be written this way: 1 plus I divided by root 2, and Z2 can be written 1 minus I divided by root 2. Okay friends, I hope it is clear. Next, friends, integration capital C z square plus 1 divided by z to the power 4 plus 1 dz equals to 2 pi I residue fz into zr. Zr means z12. Sorry, this is the number is z12. So what? How can I write? It is right. It can be written 2 pi I limit z tends to 1 plus I divided by root 2 to z minus 1 plus I divided by root 2. Z square minus 1 to z to the power 4 plus 1, and another is limit z tends to 1 minus I divided by root 2 into z minus 1 minus I divided by root 2 minus minus plus, because friends, you will see that this is this portion is minus 1 minus I root 2, this is minus z2. So how can I get this? Because z to the power 5 4 plus 1 equals to 0, so z to the power 4 equals to minus 1, and after that you can get z to the power 4 is equal to minus 1 to the power 4. 1 to the power 1 by 4. So friends, whatever we get after calculation, we get minus I divided by 2 root 2, minus I divided by 2 root 2 equals to pi root 2. How friends? Because must remember z minus 1 plus I divided by root 2 z square minus 1 divided by z to the power 4 plus 1 equals to z square minus 1. Now friends, z square into z to the power 4 plus 1 into z minus 1 plus I divided by root 2. Now friends, you will see that z to the power 4 plus 1 equals to 0. That implies z to the power 4 equals to minus 1, and z to the power 4 z square is equal to, and z to the power 4 minus 1 is equal to cos pi plus I sine pi, and z equals to plus minus cos pi by 4 plus minus I sine pi by 4. So friends, you will see that, so whatever we get, limit z tends to 1 plus I by root 2, we get z square minus 1 divided by z plus 1 plus I divided by root 2 into z minus 1 minus I divided by root 2 into z plus 1 minus I divided by root 2. This 3 factor we will get, and z minus I plus root 2, this factor is gone. And now putting this value, and this value will come minus I divided by 2 root 2, putting z equals to 1 plus I divided by root 2. So this is the process friends. How can I get this value? You will just calculation. Now we will solve another problem. Integration, this value I can write, this is omega and omega. So friends, at first I write it equals to triple integral 0 to 1 and 1 to 0 to 1. x1 x2 up to xn whole to the power t. Because this technique is very nice technique, it can be solved another way. but I like this technique. That's why I solve this way. x1, x2 and xn dot xn and ln equals to x1, x2 up to xn into dx1, dx2 up to dxn. So I dash t, how can I write? I dash t is equal to derivative with respect to t, differentiate with respect to t. So I dash t equals to 0 to 1 minus 0 to 1 up to 0 to 1 divided by x1, x2, xn whole to the power t into log x1, x2 up to xn divided by 1 minus x1, x2 xn into log x1, x2 xn into dx1, dx2 up to dxn. Now this portion and this portion is cut. So what we get? We get 0 to 1, 0 to 1, 0 to 1, x1, x2 up to xn whole to the power t divided by 1 minus x1, x2, xn dx1, dx2 up to dxn. And next friends, we use this formula summation 1 by summation x to the power n, where n equals to 0 to infinity equals to 1 by 1 minus x. That formula I will use in here. So we get 0 to 1, 0 to 1, 0 to 1 summation j equals to 0 to infinity x1 whole to the power t plus j x1 t plus j x2 t plus j up to xn t plus j dx1 dx2 up to dxn. Equals to minus summation j equals to 0 to infinity 1 by j plus t plus 1 whole to the power n. This is I dash t. You can see that, friends, I have already written that it is equal to this, and after that I am going to solve I dash t, differentiating with respect to I dash t. So I dash t, so it is equal to integration, whatever I get 1 by n plus 1, n minus 1, because how, friends? 1 minus n minus 1, must remember it is the this is the value. So it is equal to integrating with respect to dt, it is integrating. This is integrating, friends. So it is equal to 1 by n minus 1 summation j equals to 0 to infinity 1 by j plus t plus 1 whole to the power n minus 1 plus c. So, friends, this is my answer. Now I0 is equal to 1 by n minus 1 into summation j equals to 0 to infinity 1 by j plus 1 whole to the power n minus 1. This value is called zeta n minus 1 divided by n minus 1. So if n equals to 3, so whatever I get, integration 0 to 1, 0 to 1 and 0 to 1, 1 by x minus xyz minus 1 divided by ln xyz dx dy into dz equals to zeta 2 divided by 2, and zeta 2 divided by 2 is equal to pi square by 12. Zeta 2 divided by 2 equals to pi square by 12. Now we are going to solve another problem. This problem is very nice problem, friends. This problem, when we want to solve, then we can write, we know that two by root over pi zero to infinity e to the power minus a t square dt is equal to 1 by root over a. So 0 to 1 and 0 to 1, 2 by root over pi 0 to infinity e to the power minus log x yz into t square into dt into dx into dy into dz. So friends, 0 to 1 2 by root pi and 0 to infinity 2 by root over pi into minus log xyz, sorry, minus, so x to the power t, y to the power t, z to the power t. And dt 0 to infinity and 2 by root pi 1 by t square plus 1 whole cube into dt. So 2 by root pi 0 to infinity dt divided by t square plus 1 whole cube, and t square is equal to u, so 2t dt is equal to du, so dt is equal to 1 by 2, t means u to the power half du equals to 2 by root over pi equals to 0 to infinity u to the power minus half into u plus 1 whole cube into dt, and 2 cut, and equals to, we get 1 by root over pi beta. This can be written, this formula, 0 to infinity t to the power x minus 1, recall this, and 1 plus t to the power x plus y is equal to beta x comma y. So it can be written x minus 1 is equal to minus half, so it is half, beta half, and it is 5 by 2. So beta half 1 by root over pi by beta half means gamma half into gamma 5 by 2 divided by gamma 3. Three by 2 into 1 by 2 into root over pi. This pi and this pi cut, and 3 by root pi divided by 8. This is answer. So friends, again we are going to solve another problem. This problem is very interesting and very nice technique. I will apply this. xy is equal to t. So friends, whatever we get, xy is equal to t, that implies dx y dx is equal to dt. So in here limit is changing, y 0 to y, tz minus 1 divided by tz whole cube plus 1 and log zt 1/3 dx, sorry, it is dt dy into dz divided by y, and 0 to y and 0 to y 0 to 1, and this is and it can be written this way, that tz minus 1 divided by tz whole cube plus 1 into log 1/3 into t to 1 dy by y into dt into dz. So friends, this is the main problem, that if we will draw the line and we will see that 0 to x means this is the 0 to x, this is the y equals to x, and it is 0, x equals to, sorry, it is y equals to 0, y equals to 0 to x, and when it is going to this way, that x is equal to y, and the point is cutting these positions, so it is y to 1, and this equation is x equals to 1, this is x equals to 0, this straight line is called x equals to 0, and this straight line is y equals to 0, this straight line is y equals to 0. This point is 1, 0, and this is 1, 1. So this way it is going, so it is changing t to 1, 1. In here x is equal to it can be written t, this is the t axis. Okay, I hope it is clear. And now it can be written this way, 0 to 1 and 0 to 1 tz minus 1 into zt whole cube plus 1 and log zt 1/3 is equal to minus ln t dt into dz and ln t is equal to, it can be written 0 to 1, 0 to 1 tz minus 1 ln t is equal to ln k, and zt is equal to k, so t equals to k by z, so ln k minus ln z, and it can be written, tz can be written k minus 1 into k cube plus 1 into log k 1/3 into dk into dz by z, and this is z, and similarly it can be written 0 to 1 k minus 1 log k divided by k cube plus 1 log k 1/3 into dk into 0 to z, and it can be written 1 to k dz by z, and another portion is can be written minus 0 to 1 k minus 1 divided by k cube plus 1 log k 1/3 into k to 1 log z by z into dz. So friends, let log z equals to t, so 1 by z dz equals to dt, and it can be written log z by z equals to log z whole square divided by 2. So this is, it can be written this way. So whatever I get minus, and there is also a minus is left, here is also a minus, and here is also a minus, and this minus is plus. So this minus will become plus, so it is 0 to 1 k minus 1 log k divided by k cube plus 1 into log k 1/3 dk minus minus plus minus minus 0 to 1 and minus, because log z whole square, and it can be written this way k to 1, so it is obviously upper limit minus lower limit minus log k whole square divided by 2, so no chance to be, this is the minus half, so half into divided by k minus 1 log k whole square divided by k cube plus 1 log k whole to the power 1/3 into dk. Zero to 1 k minus 1 log k to the power 2 minus 1 by 3. So we get the value is 5 by 3 divided by k cube plus 1 into, or not this portion, into dk. So this is my simplifications. I hope you can understand this portion. This portion I can write, this is capital I. So I equals to, how can I write? I equals to half into 0 to 1 into k minus 1 log k whole to the power 5 by 3 dk divided by k cube plus 1. And this portion can be written this way, half into k minus 1. So it is half into 0 to 1 k into log k whole to the power 8 by 3 minus 1 divided by k cube plus 1 into dk, minus half into 0 to 1 log k whole to the power 5 by 3 divided by k cube plus 1. Let log k equals to e to the power log k equals to e to the power t log k is equal to t, that implies k equals to e to the power t. So dk equals to e to the power t into dt. So my given equation is half into 0 to 1 e to the power 2t into t to the power 8 by 3 minus 1 divided by e to the power 3t plus 1 into dt minus half into 0 to 1 e to the power t into t to the power 8 by 3 minus 1 divided by e to the power 3t plus 1 into dt. So it can be written one by 3 to the power 2 by 3 into 2 take 3t is equal to z. So 0 to infinity, limit also change, limit is also changing, and and change also minus and plus portion. So it is e to the power z by 3 into t to the power 8 by 3 minus 1 divided by e to the power z plus 1 into, it is sorry, z I can write dz, and minus 0 to infinity half into e to the power 2z by 3 z to the power 8 by 3 minus 1. One is equal to e to the power z plus 1 dz. And it can be written gamma 8 by 3 into 2 into 3 to the power 2 by 3 into 2 to the power 8 by 3 zeta 8 by 3 comma 1 by 3 minus zeta Hardwick zeta, this is called Hardwick zeta 5 by 6 minus zeta 8 by 3 comma 1 by 6 plus zeta 8 by 3 comma 2 by 3. This is the formula, friends, and gamma 8 by 3 can be written okay, I can write this is the you can use because pi by gamma 8 by 3 equals to beta 8 by 3 divided by gamma 1 by 3, because you see that beta 8 by 3 equal to gamma 8 by 3 gamma 1, so it is gamma 1 by 3, and beta 8 by 3 equal to, it can be written pi by root 3 into gamma 1 by 3. So whatever we get gamma 8 by 3 so friends, gamma 8 by 3 is equal to 10 beta 2 by 3 1 by 3 9 gamma 1 by 3 is equal to 20 pi 9 root 3 gamma 1 by 3. So friends, this is the total value, and another factor is that, friend, that this value is 2 pi divided by root 3 beta 2 by 3. Now we want to explain Hardwick eta function, eta s comma a n equals to 0 to infinity minus 1 to the power n plus x plus a whole to the power s, x plus this is the definition is something wrong. These definitions will be like this, that a plus n whole to the power s. This is called Hardwick zeta function, and Hardwick zeta functions can be written 0 to infinity e to the power minus xt, 1 plus t to the power minus t to the power x s minus 1, and zeta s comma a can be written 1 by gamma s 0 to infinity t to the power s minus 1 into 1 minus e to the power minus t to e to the power minus t a dt. This is the Hardwick zeta function, and Hardwick zeta function can be also written this way. Okay, and in the summation form, it can be written Hardwick zeta functions n is equal to 0 to infinity 1 by k plus n plus a whole to the power s. So this is the value. So whatever I get, friends, I can write this equation this way. My answer should be 10 pi root 3 divided by 27 gamma 1 by 3. I can write it Hardwick zeta form, that is this way, 8 by 3 comma 1 by 3 and minus zeta 8 by 3 comma 5 by 6 minus zeta 8 by 3 comma 1 by 6 plus zeta 8 by 3 comma 2 by 3. This is the way. So friends, I hope I can clear this concept. Now I will solve another problem. This problem is very interesting problem, friends. Let's try to solve this problem. So I can write omega equals to integration, triple integration 0 to 1, 0 to 1 and 0 to 1. 0 to 1 x y z whole to the power t dx dy and dz. It can be written t plus 1 whole cube. Next, friends, next is derivative with respect to q, d q minus 1 omega and d t q minus 1 equals to capital theta is equal to 0 to 1, 0 to 1 and 0 to 1. xyz whole to the power t and ln q minus 1 1 by xy z into dx dy into dz, and after that it can be written 0 to 1, 0 to 1 and 0 to 1, and that equals to, I can write, this is the derivative of the t, so it can be written gamma successive derivative, so gamma and t plus 1 whole to the power minus 3. Sorry, this is the writing mistake. It can be written t plus 1 whole to the power minus 3 gamma q plus 2 divided by 2 into t plus 1 whole to the power minus 3 plus q plus 1. So friends, again I will differentiate with respect to q. So d capital theta divided by d q equal to x y z whole to the power t ln q minus 1 1 by xyz into ln 1 by xyz. So friends, how it is come? Because it is the derivation. Take ln q minus 1 minus 1 by xyz. It can be ln is equal to t. So t to the power, according to the formula, t to the power q minus 1. So dt by dq is equal to t to the power q minus 1 into log t. T is equal to ln xy 1 xyz. So this is coming in here. Ln 1 by xyz into dx dy into dz equals to, if I will differentiate this, so I get gamma dash q plus t into t plus 1 minus 3 here is some mistake. This is the minus 3 minus q plus 1 divided by 2 successive derivative traits. Okay, and minus gamma q plus 2 divided by 2 ln t plus 1 into t plus 1 minus 3 minus q plus 1. Okay friends, I hope I can clear. Now I again differentiate this. So whatever I get, d square by theta divided by d q square is equal to integration 0 to 1 and 0 to 1 xyz whole to the power t ln q minus 1 by xyz divide into ln square ln 1 by xy z into dx into dy into dz. and after that the equation will be gamma double dash q plus 2 into t plus 1 whole to the power minus 3 minus q plus 1 divided by 2 minus 2 into gamma double dash 1 dash q plus 2 divided by 2 into t plus 1 whole to the power minus 3 plus q plus 1 plus gamma q plus 2 ln square t plus 1 into t plus 1 minus 3 plus q plus 1 divided by 2. So friends, I get this is the way I get. And here also ln t plus 1 because simple double derivative, friends. This is the first derivative. I get this two term digit, and after that I derivative this term. So I hope I can clear. I can take q is equal to q is equal to 1 and t is equal to 0. So I get the value is 0 to 1, 0 to 1 and 0 to 1 ln square ln 1 by x y z dx into dy into dz equals to gamma double dash 3 divided by 2 equals to 1 minus 3 gamma plus gamma square plus zeta square, sorry, zeta square, not zeta, only zeta two. Friends, this gamma is called Euler Masurian constant. Masurian constant. This gamma is called Eulerian Masurian constant. So friends, how this derivative of the zeta gamma double dash 3, that I will discuss. That d square divided by d x square gamma x, this is the note, must remember friends, this is the note, that d square gamma x is equal to gamma x is equal to di gamma x whole square minus, sorry, not minus, plus tri gamma x and di gamma x. This is the total value, friends. I hope I can clear this concept. So friends, and digamma trigamma concept I also discuss. Now we will go to solve another problem, triple integrations. I is equal to multiple integral all are 0 to 1 ln x1 whole square and ln x2 whole square dot ln xn whole square. Ln x2 dot xn x2 up to xn dx1 dx2 up to dxn. So friends, 0 to 1, 0 to 1 and 0 to 1 up to nth term, friends. In here it is nth multiple integral. So friends, into equals to 2 to the power n ln x1 ln x2 up to ln xn xn and 1 plus x1 x2 xn dx1 dx2 dxn nth multiple, friends, and 2 to the power n I will take outside, and must remember 1 divided by 1 plus x is equal to minus 1 to the power n summation n equals to 0 to infinity minus 1 to the power n x to the power n. So I apply this formula. So whatever I get summation n equals to 0 to infinity minus 1 to the power n into x1 x2 xn whole to the power. This is very suitable that do not write in here n because n is ultimate in here. So it is k minus 1 to the power k into to the power k and ln x1 ln xn ln x1 x2 xn and dx1 dx2 and dxn. equals to 2 to the power n 0 to 1, 0 to 1 up to 0 to 1 summation k equals to 0 to infinity x1 x2 up to xn whole to the power k del del t1 x to the power t1 as t1 tends to 0, because friends, this type of problem, when ln x is in here, so here is the derivatives. 1 ln means 1 derivative and 2 ln means double derivative, ln square. So I apply this issue as ln x is in here. So del t 2, so x to the power t2 up to del x tn x to the power tn as t2 tends to 0, tn tends to 0, so on, and del del s x1 x2 up to xn whole to the power s as s tends to 0, because friends I apply this formula as ln is in there here, so I can use one derivative and this term. So friends, whatever you see, this is the technique. This technique is very important. 0 to 1, 0 to 1 and 0 to 1. We get del del t1 del del t2 up to del del tn. Summation j equals to 0 to infinity minus 1 to the power j. So I just remove this integration part in here. Because integration is based in here. So it is 2 to the power n and 0 to 1 x1 whole to the power j plus t1 plus s into dx1 into 0 to 1 plus x2 to the power t plus j plus s into dx2 into 0 up to 0 to 1 nth term, friends, xn j plus t plus s dxn. So friends, whatever we see that this is the value is 2 to the power n 2 to the power n n del by del t1 del by del t2 up to del by del tn summation j equals to 0 to infinity minus 1 to the power j divided by j plus t plus s plus 1 t1 and j plus t2 plus s plus 1 up to n j plus tn plus s plus 1. And del del s. So it can be written to the power n del del s is equal to 0 summation j equals to 0 to infinity minus 1 to the power j plus n divided by j plus s plus 1 whole to the power 2n as t1 t2 everything tn tends to 0 is equal to n into 2 to the power n minus 1 summation j equals to 0 to infinity minus 1 to the power j divided by j plus 1 whole to the power 2n plus 1. It can be represented as in the way that n into 2 to the power n minus 1 n plus 1 it is 2 to the power n plus 1 sorry after derivative I get this portion. So this portion and it can be written this way minus 1 to the power n plus 1 eta 2n plus 1 so for n equals to 3 we get 0 to 1 0 to 1 and 0 to 1 ln x square ln y square ln z square ln into ln x y z divided by 1 plus x y z into dx into dy into dz equals to 48 eta 7. How friends? You will see by the generalizations. What is my generalizations friends? I will show the generalizations is that in here 3 into 16 into eta 6 plus 1 so eta 7. So this is my answer. I hope no doubt. So I write the answer in my question 48 theta. Now the question number 9, in triple integration 0, 0 and 1, 1 xyz ln xyz dx dy dz. So friends, I will apply the generalization, same formula, 0 to 1, 0 to 1, 0 to 1. Okay friends, I think this problem I have already done. I just solve it again, but this problem I have already done. Yeah, this is my problem. This problem, question 9, question 4 is the same type of problem, friends. We have already done, so don't need to solve this problem. So we are going to solve number 11. So it is this problem is very interesting, friends. This problem is very interesting. So let's try to solve. I equals to triple integral 0 to 1 and 0 to 1, 0 to 1 z square minus 1. So friends, this is my I. So I can use symmetry formula. Using symmetry and dx, dx, dy, dz, this is I. It can be written this way: 0 to 1, 0 to 1 and 0 to 1, and x square log x z square, and x square plus y square plus z square into x square y square z square minus 1 into dx, dy and dz. So using symmetry, I used in here symmetry. So friends, symmetry I used, so I get this, and after that I get 2i equal to 0 to 1, 0 to 1 and 0 to 1 into x square log x square y square and z square. X square z y square z square minus 1 into dx dy into dz. So just adding, just using property of logarithm, and after that 0 to 1 and 0 to 1 and 0 to 1, I used symmetry property. It can be written this way: I is equal to x square log xyz divided by x square plus y square plus z square, x square y square z square minus 1 into dx dy into dz. And again I will use if I will use symmetric property, then 0 to 1, 0 to 1 x square log xyz, it can be written y square log xyz x square plus y square plus z square dx dy dz, z square log xyz y square plus z square dx dy dz. So friends, this is my total answer. So what I get if I add 3i symmetric property I use, so 0 to 1, 0 to 1 and 0 to 1, I get x square plus y square plus z square log xyz divided by x square plus y square plus z square into x square y square z square minus 1 into dx dy into dz, so that I get the value is coming 0 to 1, 0 to 1, 0 to 1. This portion is this portion cut. X square plus this portion and this portion cut. So I get log of x, y, z divided by x square, y square, z minus 1 into dx, dy into dz. After that, next is the triple integration 0 to 1 and 0 to 1. I using the property of symmetry, so I is equal to I is equal to 3 into log x divided by x square, y square, z square minus 1 dx dy and dz, and 3 cut. So I get this value, and after that I can write this way equals to minus 0 to 1, 0 to 1 and 0 to 1 log x summation n equals to k equals to 0 to infinity xy z whole to the power 2k dx dy and dz and equals to summation k equals to 0 to infinity minus 1 by 2k plus 1 into 2k plus 1 into 0 to 1. This is because y to the power 2k and z to the power 2k. So y to the power 2k integration of 0 to 1 y to the power 2k dy is equal to 1 by 2k plus 1 and integration 0 to 1 z to the power 2k dz is equal to 1 by 2k plus 1. So whatever I have, x to the power 2k into log x into dx. So friends, when you see the log x, then you will work this way: k equals to 0 to infinity 1 by 2k plus 1 into 2k plus 1 into differentiations del s, where s is equal to 0. So 1 by 2k plus s, 2k plus 1 into s. So friends, again if we differentiate, and after that we will get summation k equals to 0 to infinity 1 by 2k plus 1 whole to the power 4. This value is pi to the power 4 divided by 96. So friends, how this value is pi to the power 96? Must remember zeta 4. Must remember zeta 4 is equal to summation k equals to 0 to infinity 1 by k to the power 4. And now this value is pi to the power 4 divided by 90, and 1 by k to the power 4 equals to, can be written, k equals to 0 to infinity, k is equal to 1 to infinity, k is equal to odd value 1 by odd value. So it is okay, 2k plus 1 whole to the power 4 equals to 0 to infinity. It can be written. Another value is summation k equals to 1 to infinity 1 by 2k whole to the power 4. So 2k 1 to the power whole to the power 4 can be written. So it is not k equals to 1 to infinity, k equals to 1 to infinity 1 to infinity. It can be written k is equal to 0 to infinity, it can be written k equals to 0 to infinity in here, or in here k equals to 1 to infinity. So 2k whole to the power 4, and it can be written k equals to 1 to infinity 1 by 16 1 by k to the power 4. This value is zeta and this value is zeta. So after that we get 15 by 16 zeta 4 is equal to summation k equals to 1 to infinity 1 by 2k plus 1 whole to the power 4. So friends, very simple. I hope you can understand. So friends, now we will solve this problem. Double integration 0 to 1 log x log y log xy 1 divided by 1 minus xy dx into dy. So friends, this problem can be written this way: 0 to 1 and 0 to 1 log x into log y into log xy. divided by xy dx dy. So friends, I can write it omega, this symbol, and after that I can write this is this way: 0 to 1, 0 to 1 log square x log y divided by 1 minus xy dx dy plus 0 to 1, 0 to 1 log squared y into log x divided by 1 minus xy dx into dy. So friends, using symmetry we have I is equal to 2 into 0 to 1, 0 to 1 log square x into log y divided by 1 minus xy dx into dy, and after that we can write 2 into summation n equals to 0 to infinity 0 to 1 y to the power n log y and 0 to 1 x to the power n log x dx. So friends, these are log square x. So whatever we will do, we can write summation n equals to 0 to infinity del s y to the power divided by n plus 1 in plus s writing right very clear way del s into n plus 1 plus s into del k del square into del k square 1 by n plus 1 plus s. So this value is double derivative, so it is minus 2 into n plus 1 whole square, and this value when I will using successive derivative, then it will become 2 divided by n plus 1 whole cube, as ddx of x to the power n equals to n into x to the power n minus 1. This formula I use. So, and ddm, so this is the another formula, successive derivative formula. So I just apply this formula, then I get 4 divided by n plus 1 whole to the power 5 is equal to minus 4 eta 5. Sorry, not eta, it is zeta. And it is the formula is n equals to summation n equals to 0 to infinity n equals to summation n equals to 0 to infinity, and this is the zeta phi. So friends, I hope I can clear this concept. So this is my answer. Next I will go to solve this problem. Double integrations, but this type of questions is coming in competitive examinations. So let's try to solve this problem. So this is the region is ellipse. So changing solution, changing ellipse to circle. So how can I convert it ellipse to cycle? X is equal to AU and Y is equal to BV. Y is equal to BV. So J equals to A00B and it would be AB. Hence the given double integrations. Hence the given double integration our integration is double integral capital R root over a square b square. You will see this integration a square b square minus x square. So a square b square and b square x square minus a square y square divided by a square b square minus plus b square x square plus dx and dy. So whatever we get double integral, just putting the value x is equal to AU and b is equal to BV. So whatever I get AB root over 1 minus u squared minus v square divided by 1 plus u square plus v square du into dv. So my equation is u square plus v square is equal to 1. So I changing the coordinate. So my problem is positive coordinate, friends. You will see that the integrations is the positive coordinate of ellipse. So let's try to draw to show what is the positive coordinate, friends. This is a line. Yeah, this line is not good showing. This is a line and this is my axis and this is my ellipse. Ellipse equation is x square by a square y square by b square is equal to 1. So they just ask that this portion I have to find out. Okay, this portion I have to find out. So this equation you can say x is equal to, this is x equals to 0 and this is y equals to this portion is this portion is y equals to 0 and this portion is x equals to 0 and this is x and this is x dash, this is y and this is y dash. AB integration root over 1 minus r square divided by 1 plus r square and if we will consider the circle then it is considered a circle, then it is 0 to pi by 2. So it is 0 to pi by 2 and 0 to 1 and dr into d theta. Just changing the double integration rule. After that, whatever we get, and Jacobian is r in case of u equal to r cos theta and v equals to r sine theta. So my Jacobian is r. So r is equal to this, and Jacobian means transformation coordinate. Jacobian is del x y z. Sorry, x y means in here uv. Sorry, it is uv divided by del x comma del r comma theta. So this is my answer will come r. So after that I can write AB double integrations. One is 0 to 1 and 0 to pi by 2 here d theta and root over 1 minus r square divided by 1 plus r square into r into dr. So whatever we get very simple, AB pi divided by 2 and r square and r square, if we will get, so 0 to 1 and divide by 4 root over 1 minus r divided by 1 plus r into dr. How? Because take r square is equal to r. And after that I can write AB pi divided by 4, 0 to 1 can be 0 to 1, okay, no problem. It is dr divided by root over 1 minus r square, and another fact is that 0 to 1 r divided by root over 1 minus r square dr. So friends, what we get, what is the formula? Integration dx divided by root over a square minus x square is equal to sine inverse x by a. So integration AB pi divided by 4 into sine inverse r and limit is 0 to 1 and half into 1 minus, take 1 minus r square is equal to t, so minus 2r dr equals to dt. So 2r into dr means half into 0 to, if I will put in here 0, so it is 0 to 1, minus minus, it is the changing, and it is dt divided by root t. So this value will come in ab divided by pi by 4, and sine inverse 1 is equal to pi by 2. Sine inverse 1 equals to pi by 2, and this value is t to the power minus half plus 1, so divided by minus half plus 1, and 2 will cut, that the value will be 1. Pi by 2 minus 1. I hope that I can clear this concept. Next we will go next problem. So next problem is double integral dx into dy divided by 1 plus x square y square whole square. Now how can I solve this problem? You will see that x squared, this loop, you will see this loop is Leibniz-Gate. So this diagram should be, so friends, to solve this problem, take x is equal to cos theta and y is equal to sin theta. I hope I can clear this concept. X is equal to cos theta, r cos theta, and y is equal to r sin theta, and if I will putting this value, then I get r to the power 4 minus r square into cos square minus sin square theta, cos square theta minus sin square theta equals to 0. So equals to 0. So whatever I get, r square is equal to cos 2 theta, and r square is equal to cos 2 theta. I have already drawn. This is my graph. You will see this is my graph. My graph would be this kind, and r and theta is moving 0 to pi by 4, and r is equal to, what is the value of r? R is equal to root over cos 2 theta. So let's try to solve this problem. So integration is 0 to pi by 4 according to the theta condition, and it is 0 to root over cos 2 theta. 0 to cos 2 theta, and Jacobian j equals to r, and we have that dr into d theta divided by 1 plus r square whole square into r. So this is the one loop. So half has been shaded, so it is 2 times multiply. We multiply with 2. So whatever I get 2 into pi by 4, because d theta will be in here. So this is pi by 4, and r square divided by these equations, zero to root over cos 2 theta, it can be written d r square divided by 1 plus r square into half. Sorry, there is a mistake in here, that d theta is already dependent, so I cannot not putting this value pi by 4. So I just remove this and write this way, 0 to pi by 4 into d theta, it can be written so that we get the value, it is the whole square, and we can get minus 1 by 1 plus r square, 0 to root over cos 2 theta. Minus 0 to pi by 4 1 plus cos 2 theta. There is some mistake. This is minus 1 into d theta. So minus 0 to pi by 4 1 plus cos 2 theta equal to 2 cos square theta. So 1 by 2 cos square theta minus 1 into d theta, and it can be written sec square theta. So 0 to pi by 4 half sec square theta d theta minus integration 0 to pi by 4 d theta equal to half into tan theta 0 to pi by 4 minus pi by 4. So this value is half minus pi by, this is plus, this is minus, this is plus, this is minus, this is plus. So there is some mistake. So I hope that you can understand these questions, this problem. Next, double integral capital R root over 4a square minus x square minus y square dx into dy. So how can I solve this problem? Problem is very simple. X is equal to r cos theta, y is equal to r sine theta. So equals to 0 to, and now you will see that this equation is given, my curve is x square plus y square plus minus 2x. So x is equal to, we change, and j equals to obviously r. J equals to obviously r, we know. Now whatever we get from these equations, that r square minus 2a r cos theta equals to 0. So r is equal to 2a cos theta 0 to pi by 2 into 0 to 2a cos theta r into root over 4a square minus r square into dr into d theta. Very simple. After that, I putting this 0 to pi by 2 as it is a domain. The limit is based on theta, so I cannot use d theta integral. So they are dependent. R is dependent on theta. So I will work with this. So integration 0 to 2a cos theta divided by into r root over 4a square minus r square dr into d theta. Now take 4a square minus r square is equal to t. So minus 2r into dr equals to dt. So what can I do? So I can write this way: 0 to pi by 2 into putting this value, and limit should be changed. When r is equal to 2a cos theta, okay, no problem, I will not change the limit. I just write 0 to 2a cos theta minus half into root over 4a square minus r square d into 4a square minus r square. Okay, so this way I can write, and d theta, and it can be written this way: 0 to pi by 2, and this formula is minus half into t to the power half, what means t to the power 3 by 2, it's 4a minus r square to the power half plus 1 divided by 1 by 2 plus 1, and putting the limit 0 to 2a cos theta. So what I get into d theta. So what I get 0 to pi by 2, just putting the value of the 2a cos theta value. So this value will become, just simplify, friends, simplifications, just some simplifications. So whatever I get, 8 by 3 a cube integration 0 to pi by 2 sine cube theta into d theta. So this value will become 4 by 9 a cube into 3 pi minus 4. So what is the formula, friends? 0 to pi by 2 formula: sine to the power n dx. So this formula is n into n minus 1 up to 1 and n minus 2 up to this, up to this way. So here whatever we get 0 to pi by 2 sine cube x dx. So it is 3 into 2 divided by, so here is some mistake in here, sine to the power nx dx formula. sine to the power nx dx is equal to n minus 1 n minus 3 up to 1 divided by n into n minus 2 n minus 4 up to this. So this is the formula, friends. So whatever I get 3 minus 1, so the formula will become 3 minus 1 means 2 into n minus 3, so it will not necessarily, and this is 2 by 3, and if here n is odd positive number, 3 is odd, so no need to write pi by 2, so 2 by 3, this is the, that's why I can get very simple simplifications, friends. This simplification is very simple. That how can I get? I will also show this. 8 by 3 a cube pi by 2 into pi by 2 minus 16 by 9. So just take common 4 by, and this portion is cut in here, so it is 4. So 4 by 9 a cube is equal to 3 pi minus 4. This is the answer, friends. I hope I can clear this concept. Next problem, friends. Next problem is very interesting problem, and I hope this is the last problem. So let's start solution, and at first I read the questions. Prove that double integrations 2a squared minus 2a x plus 1 minus x squared plus y squared dx dy. So how can I solve this problem? I is equal to integration r 2a squared minus 2a x plus y minus x square plus y square dx dy. So friends, we can write x is equal to r cos theta and y is equal to r sine theta. X is equal to r cos theta, y and j equals to r. So sorry, x is equal to, in here x is equal to r cos theta plus a r sine theta. This is not actually correct. This way x is equal to, because the question you have to see is the region. This region can be written this way: x square plus 2ax plus a square plus y square plus 2ay plus a square is equal to 4a square. So friends, whatever we see, x plus a whole square into y plus a whole square is equal to 4a square. This way we get. So if I get this way, so whatever I can write x plus a and y plus a is equal to r cos theta r sin theta. So my given equation, given relationship can be written this way: double integrations 4 square minus x plus a whole square minus y plus a whole square into dx dy. It can be written, and region is E, because I just add in here 2a square and minus 2a square. So this is equation, double integration. I give double integrations, and x plus y, x plus a whole square, y plus a whole square is equal to 4 square minus r square into r to dr into d theta. How this is r? Because we know the Jacobian is r. Jacobian is r, and the circle is the full region. So it can be written this way. At first I draw that circle, and this circle regions, first region is 0, theta is equal to 0 to pi by 2 we get. So 4 into multiplier 0 to 1 and 0 to pi by 2, it can be written, and just putting 4 square minus r square into r square dr into d theta. And as r is not, it is not dependent on theta, so I can write this way: 4 into 0 to 1 0 to pi by 2 d theta into 0 to 1 4 square minus r square into r into dr, and value should be 4 into pi by 2, and the value is, and 0 to not a, 0 to, sorry, actually the r value is 2a, r is equal to 2a, so it is 2a, it is 2a, so I get the value 4 square divided by 2a whole square divided by 2. It is not correct this way. It is 4 square multiplied with 2a minus r cube, means r to the power 4. So 2a whole to the power 4 divided by 4 into this way. This way I can write, and it is 2a square by 2. So my calculations, after the calculation, I get 8 pi a to the power 4. This is my answer. I hope I can clear this concept. Thanks. So friends, let's try to solve this problem. Triple integration 0 to 1 arc sine xyz log xyz dx dy dz. So friends, it can be written xyz whole to the power a sine inverse ia equal to, same technique friends I will apply in here, because as the technique is same, so we will solve a lot of category problem. Like this type of technique I will use this technique. This is the one kind of technique. Another technique is, you will see procedure, that this kind of technique, this technique I will use in the problem number 9. So friends, my target to solve total 20 problems I will solve today. So log xyz dx dy into dz. So it can be written I dash a is equal to 0 to 1, 0 to 1, 0 to 1, xy z whole to the power a sine inverse xy z dx dy dz. Now we use the formulas arc sine series. Arc sine x equals to summation n equals to 0 to infinity minus half into n minus 1 whole to the power n x to the power 2n plus 1 divided by 2n plus 1. It can be written this way: summation n equals to 0 to infinity combination coefficient k c to k divided by 4 to the power k divided by 2k plus 1 into x to the power 2k plus 1. So I dash a equals to triple integration summation k equals to 0 to infinity xy z whole to the power t plus 2k, sorry it is a, plus 2k plus 1 dx dy and dz. A plus 2k plus 1 dx dy dz. So it can be written this way: 0 to 1 and 0 to 1 and 0 to 1 summation k equals to 0 to infinity another fact I have missing, I just missed in here. It can be written k c to k divided by 4 to the power k into 2k plus 1. It can be written this way. So it can be written k c to k divided by 4 to the power k divided by 2k plus 1, and a plus 2k, so it is x to the power a plus 2k plus 1 dx xyz yz whole to the power a plus 2k plus 1 dx dy and dz, and after that it can be written this way: summation k equals to 0 to infinity k c to k divided by 4 to the power 2k, sorry, 4 to the power k into 2k plus 1 2k plus 1 and 2k plus 1 whole cube. Plus 2 whole cube, sorry, 2k plus 2 plus a whole cube as integration x to the power a plus 2k plus 1 0 to 1 dx is equal to 1 by a plus 2k plus 2. This is the formula. So similarly there is a 3 2k plus a plus 2 whole cube. Okay, and now a tends to a equals to z tends to 0. Sorry, a tends to 0. Yeah, yes, okay, a tends to 0 because I dash a. Okay, no problem. At first I will not, it is not, I don't need to a tends to 0. I will after integrations I will put this in here. So I dash, so whatever I get, I dash a equals to 0 to 1, 0 to 1 and 0 to 1, 1 summation k equals to 0 to infinity ck to k divided by 4 to the power k into 2k plus 1 into 2k plus 1 plus a, sorry, it is not plus 1, it is plus 2 whole cube into not triple integrations, this is the I dash value, I dash a value. Okay, and plus c, you will must remember that here plus c, as a tends to infinity, c tends to 0, so this is my total value. A c to k 4 to the power k, 2k plus 1, 2k plus 2 plus a whole cube. Now friends, whatever I get equals to IA minus half summation k equals to 0 kc2k divided by 4 to the power k 2k plus 1 divided by 2k plus 2 plus a whole square. Okay friends, I hope it is clear. So my question is I0. IA and this value is equals to I0. So this is my question is I0. So I can write this way. I0 is equal to minus half summation k equals to 0 to infinity k c2k divided by 4 to the power k 2k plus 1 into 4 into k plus 1 whole square. 4 into k plus 1 whole square. Now this value is equals to kc2k arc sine x is equal to summation k equals to 0 to infinity kc2k divided by 4 to the power 2k 2k plus 1 into x to the power 2k plus 1. Okay, I hope it is clear. And another factor is friends, another factor is that log integration of 0 to 1 sine inverse x log x equals log x dx equals to, we get summation k equals to 0 to infinity kc2k divided by 4 to the power 2k into 2k plus 1 into 4 into k plus 1 whole square. So friends, this is the value. So friends, this value is equals to C. This value is equals to minus value. Okay, this is the minus. So, and this value equals to pi by 2 minus pi by 2 minus log 2 equals to minus summation k equals to 0 to infinity kc2k. So this is the value. So friends, this value I shall prove in my next problem. So whatever I get the value is 1 minus pi by 4 minus half log 2. This is my answer. I hope I can clear this concept, but I will prove this in my next problem. It is already already given. I will prove it in this video. I will prove. Now I left these questions. I have to solve this problem. So friends, now we are coming to solve another problem using transformation x plus y and y equals to uv. Show that 0 to 1 dx, and this equation becomes these equations, and where E is the triangle bounded by x equal to 0 equal to y equals to 0. So friends, the y values is 0 greater than equals to x greater than equals to 1. This is the total factor y value in ranges for 0 to and ranges the y value. I write it in here. Y values for ranges for 0 to 1 minus x. Hence, the region E is the region OAB. So friends, I will draw the axis. It should be this type of problem. So 0, 1 x plus y equals to 1, and 1, 0 so it is x equals to 0, it is y equals to 0. So whatever you see that thus 0 to 1 dx and 0 to 1 minus x e to the power y divided by x plus y into dy. So region is OAB. You will see. So it is easily show that it is double integrations e into e to the power y divided by x plus y. So x plus y equals to u and y equals to uv and x equals to u into 1 minus v and y is equal to uv. So j equals to del x comma y del into u comma v. xu yu so this value derivative is 1 minus v into u and minus u into v equals to u. So this is Jacobian equals to u, and our next E equals to, E is bounded by x equals to 0, y equals to 0, x plus y equals to 1, transforms into E dash, transform into E dash. Bounded by u equals to 0, v equals to 0, 1 minus a unit square. In the UV plane, so I equals to double integration e to the power x plus y dx dy equals to double integral e to the power uv into u into du into dv. You will see that I have already told that x plus y equal to u and y equal to uv. And u cut, and the 0 to 1 u du into 0 to 1 e to the power v dv equals to u minus 1. So this is my answer, friends. And next I will go to solve some problem number 17, and another 3 problems I will solve, because this course is very large, because we have to explore a lot of problem, lot of topics. That's why our video is very lengthy. However, people will watch or not, this is good, but we need to explore a lot of knowledge from the video. So let's start to solve this problem. For the area, integrate r sine theta over the area of cardioid equal to r equals to a into 1 plus cos theta lying above the initial line. So for the area of the cardioid, r is equal to a into 1 plus cos theta, 1 plus cos theta, and 0 to theta, where theta varies 0 to pi, and r equals to 0 and 2, r equals to a into 1 plus cos theta. So initial line A denotes the region consisting of the area of the cardioid lying above the initial line. Then the required integral is double integral area equals to, I can say this is the area, this is the area, equals to double integral r sine theta into dA. So this value is 0 to pi into 0 to a into 1 plus cos theta r sine theta into r into dr into d theta. Equal to pi into 0 to sorry, in here it is not pi is used in here. Zero to a into 1 plus cos theta into 0 to pi r square into sine theta so we can write this way 0 to pi sine theta into r cube divided by 3 0 to a into 1 plus cos theta. A cube theta 3 divided by 0 to pi into sine theta divided by 1 minus cos theta whole cube into d theta. So it can be written this way. A cube into 8 divided by 3 0 to pi into sine theta into 2 sine theta by 2 cos theta by 2 into sine square sine to the power 6 theta by 2 d theta. So it can be written 8 a cube divided by 3 into 0 to pi, it is not 3, it is 16. This value is 16, 0 to pi by 2 and 0 to pi by 2 sine phi and cos to the power 7 phi d phi. So friends, this is the 16 not possible, this is 32. How? Because theta by 2 is equal to phi. So d theta equals to d phi. So friends, this is the 332 a cube divided by 3 and it can be written this way that minus cos to the power 8 phi divided by 3 divided by 8 and it can be written into 0 to pi by 2. So it can be written 32 a cube by 3 into 1 by 8 equal to 4 a cube by 3. So I hope I can clear this concept. Now next I will solve this problem. So 0 to 1 and 0 to 1 minus x equals to minus 1 by 2 1 plus x plus 1 by z whole square 0 to 1 minus x minus y into dx into dy. So whatever we get if we putting the value in here z value, so we get 0 to 1 0 to 1 minus x 1 by 4 plus 1 by 1 plus x plus y minus y by 4 plus just putting the value now just differentiate integrate it minus y by 4 minus 1 plus x plus y into 0 to 1 minus x into dx into I hope dy is not in here, so dx. Zero to 1 minus half minus minus plus 1 by 1 plus x dx, just putting upper limit and lower limit, and after that whatever we get half into 0 to 1 minus 3 by 4 plus 1 by 4x plus 1 divided by 1 plus x into dx equals to half, just integrating, after integrating whatever I get minus 3 by 4 plus log 1 plus x into 0 to 1 half 3 by 4 plus 1 by 8. Now friends, we are solving another problem. 0 to log x, 0 to x, 0 to x plus log y, e to the power x plus y plus z. How can I solve this problem? So after integrating, we have e to the power x plus y plus x plus log y plus, so it is not plus, it is minus e to the power x plus y dx into dy. Dx into dy. Okay. So 0 to log x, and we get e to the power 2x into y into e to the power y. And integration also 0 to x and e to the power x into e to the power y. E to the power 2x y into e to the power y dy minus 0 to x e to the power x into e to the power y into dy into dx. So friends, whatever you see first term, and this is log. There is some question mistakes. It is log 2. It is log 2. So it is x plus log y equals to this z. It is y equals to x. That is x equal to log 2. So this is the distribution. So I hope I can clear log 2. So I hope I can clear, and my limit is sum. It is 2. It is 2. Log 2, and after that I just, this is the IBP, I using IBP. So integrating by parts. So whatever I get this value is, will come e to the power 2x and x into e to the power x, because I just integrating by parts, and e to the power 2x into e to the power x minus 1. and another factor is in here e to the power 2x plus e to the power x into dx. This is coming in here. After that I will solve this problem, that 0 to log 2 e to the power 3x into x dx is equal to, now I will apply IBP rules. 1/3 x into e to the power 3x 0 to log 2 and 1/3 0 to log 2 e to the power 3x dx. And IBP, I using just IBP fields. Okay, I just using IBP. So e to the power 3x dx minus 0 to log 2 0 to log 2 e to the power x dx. So just putting this value, and whatever I get, 8/3 log 2, just by putting in here. So this is 8/3 log 2, 4/9, 8 minus 1 plus 2 minus 1. So my answer will come 8/3 log 2 plus minus 19/9. So I hope I can clear this, friends, that this is the total concept. I will clear this total concept, friends. 19. Now next I will go this problem, because this answer we know all. I have already told my previous solution. Then 2 minus log 2 minus pi/2. You will see it in my previous solution. That number 9, you will see that I use this equation, this in here. So my answer is, so you know that my answer, this value is equal to log 2 minus pi/2. So this value will come 1 minus half log minus pi/4. So friends, now let's start to solve. How to solve this problem? So friends, at first I want to solve this problem in indefinite process. So it is log x sine inverse x dx. So it can be written this way, IBP, using IBP. So it is log x sine inverse x into x minus integration ddx into log x sine inverse x. Integration dx, after that dx. So this is the way. After that, how can I solve? I can write this way, x into log x sine inverse x minus d dx of log x is equal to, it can be written sine inverse x by x plus log x divided by 1 minus x square into x into dx. So it can be written this way: x into log x sine inverse x minus integration sine inverse x. So friends, we will solve it step by step. I will write it is a I1 and this is I2. So at first I will solve I1. So whatever I get, integration sine inverse x dx is equal to x into sine inverse x minus root over x divided by root over 1 minus x square dx, and 2x into 2. So it can be written x into sine inverse x minus 2 into minus plus root over 1 minus x square. I hope I can clear, because 1 minus x square is equal to, take it is t. So minus 2x dx is equal to dt, and minus 2x dx means minus x into dx is equal to dt divided by 2. So it is dt by 2, and in here by 2. So integration t to the power minus half dt equals to integration t to the power half divided by half. So this half and this half will cut, so it will become x into sine inverse x plus 1 minus x square. So this is my answer. So I write down in here log x sine inverse x minus x sine inverse x minus root over 1 minus x square. Again we will solve I2. What is the value of I2? I2 is equal to integration x into log x root over 1 minus x square dx. So how can we solve this? Similarly, take 1 minus x square in here. 1 minus x square is equal to u square. So minus 2u 2x dx is equal to 2u is equal to 2u du. So minus x dx is equal to u du. So it can be written minus. So how can I have to do IBP. I want to do IBP. So log x is first term. Log x is first term. Second term is x into root over 1 minus x square dx, and minus log x, differentiating of log x. So it is come dx divided by root over 1 minus x square as the formula UV formula. Integration of UV dx is equal to u into v dx minus u du into dx into v into dx, and after that, so whatever we get log x x into root over 1 minus x square. It can be written as I have taken already. I have already told that it is u square so it is u square, and this portion is x square, so it is sorry, I just making a lot of mistakes. It's not this. It will come ddx of log x integration x by root over 1 minus x square into dx. I will write in here dx. So it is now now the process is going in here that x squared 1 minus x square is equal to u. So what we get in here, minus 2x dx is equal to du. So it is divided by 2. Okay, it is divided by 2, and u to the power half minus half plus 1. So it is also u to the power, it can be written root over 1 minus x square into 2. So 2 cut. It is 2 cut, and the value will come this way. So it is minus root over 1 minus x square divided by x. This will become plus log x root over 1 minus x square. I hope I can clear this concept. And now in here we get minus log x root over 1 minus x square and plus dx, and integration it will become 1 minus x square is equal to 1 minus x square is equal to u square. So it is u square divided by 1 minus u square du, and minus log x root over 1 minus x square plus u square can be written minus 1 plus 1. So minus plus root over 1 minus x square because in case that what you see, what u square 1 minus 1 minus u square divided by 1 minus u square, then it is this way it can be written minus du divided by 1 minus u square. So taking the formula log x root over 1 minus x square plus root over 1 minus x square half into log 1 plus u divided by 1 minus u, and it is the better that this way is will come problem, will be coming problem. So I can write this way, take it in here plus, it is minus, it is plus, so it is u plus 1, u minus 1 divided by u plus 1, and must remember friends that integration dx divided by x square minus a square is equal to 1 by 2a log of a minus x divided by a plus x. So this formula I use in here. So friends, I just putting the value of u log of x root over 1 minus x square plus root over 1 minus x square minus half into log 1 plus x square minus 1 root over 1 plus x square plus 1. So after simplifications, whatever we have got that minus log x root over 1 minus x square plus root over 1 minus x square minus of log root over, there is a plus, so root over 1 plus x square plus 1 plus log x plus c. So this is my total value, friends. I just putting this value plus I2 I will write, and this value is, it can be written as I. So I equals to minus 2 into root over 1 minus x square plus root over 1 minus x square minus 1 log x plus log root over 1 plus x square plus 1 plus x into log x minus 1 into sine inverse x 0 to 1. Just putting this value, and after that what can I do? I just putting this value, whatever I get minus 2 in here, and another factor in here. If I will put that it is 0, and minus log 2 I get, and plus pi by 2. This is my answer. Thanks for watching.